So today we're going to talk about parent functions and their graphs and their transformation. So let us begin. The very first function that we're going to talk about, as you know, is the constant function. Constant function. This function represented by y equals to c, or if you use the function notation, f of x is equal to c. This is just constant. No matter what your x is, your y value is always fixed. Very well. The second one is linear function. For a linear function, y equals to mx plus b, or in general, f of x is mx plus b. You have a line, either increasing line or decreasing line, or you have a flat line. This graph is either increasing or it is decreasing, or you have a flat line. Just a little bit here. So we have a spline for the flat line. So for each case, we can just analyze the slope of the line. M is positive because the graph is increasing. M is negative because the graph is decreasing. And in this case, you have a flat line. M is equal to 0. There you go. What is the next function? The next function, as you remember, is quadratic function. For a quadratic function, we denote this by f of x equals to ax squared plus bx plus c. Remember that when we discussed this quadratic function, we just went over examples about the axis of symmetry. Guys, to find the axis of symmetry, x must be minus b divided by 2a. We cannot just take b and divide it by 2. As you saw in many examples, that is not the axis of symmetry for a quadratic function. We also learned that to solve this quadratic equation, to find zeros, we have x equals to negative b plus minus square root of b squared minus 4ac divided by 2a. This gives us the solutions, zeros, or x-intercept of the points on the horizontal axis that the graph has intersection with x-axis or horizontal line. Remember that when we are dealing with quadratic functions, if a, which is the leading coefficient, if a is positive, then the graph opens up. So if your a, or the leading coefficient, is positive, the graph opens up. We call it a parabola. So the name of the graph of a quadratic function is parabola. Well, if a is negative, then it opens down. The parabola opens down. Remember that. We said, hey, if a is positive, we end up with a minimum for our function. And if a is negative, we end up with a maximum for our function. Very well. The next function that we're interested in working with is called the power function. Power function of degree 3. So if we have a power function of degree 3, we can denote that this way. F of x is equal to ax to the third. If you have a power function of degree 3, the behavior of the graph will be like this. If a is positive, then the graph is an increasing graph. A is positive, we have increasing graph. But if A is negative, then we have a decreasing graph. A is negative and we get a decreasing graph. Very well. Next function that you're interested in working with is called absolute value that you saw before. So I'm going to erase these two. Absolute value function is one of the parent functions that we need to know the definition. Number 5 is absolute value function. Either y equals to absolute value of x, or the identical for y is f of x. F of x is equal to absolute value of x. Well, remember that the graph is a V-shaped graph. X, y. This is a piecewise defined function. Guys, this is a piecewise defined function. On one piece, it behaves like this, decreasing line. On the other piece, it's an increasing line. This is your absolute value function. The next function, well, now we're going to talk about the reciprocal function, which is defined this way. The reciprocal function. This function is y equals to 1 divided by x, or you can write the identical to y, which is f of x, equals to 1 over x. When we want to graph this function has two parts. One part of this graph is on the first quadrant, and the second part of the graph is in the third quadrant. So this is your reciprocal function. Note that it's not defined at 0. This function is not defined at x equal to 0. 1 divided by 0 is infinity. Let us write this down here. 1 over 0 is, in algebra, we say that it's undefined. So remember that. 1 divided by 0. In algebra, we say that undefined. But when it comes to calculus, we say that, hey, 1 over 0 is infinity. In calculus, it is infinity. In calculus, we're going to learn more about the behavior of a number divided by 0. So remember that when we go back to algebra, we don't know anything about calculus in algebra. So we say that, hey, 1 divided by 0 is undefined. But in calculus, when you see 1 over 0, we have infinity. Y equals to 1 over x is called the reciprocal function. You need to know the name of these parent functions. F of x equals to 1 over x, either represented this way or represented by f of x. The function is not defined at x equal to 0 in algebra terms, but when it comes to calculus, when you learn calculus, remember that we say that it's infinity. There you learn about the limit when you go to the right-hand side, when you go to the left-hand side, and more topics. Number 7. Number 7 is called exponential function. Exponential function. Well, exponential function is denoted as y equals to b to the x, or f of x equals to b to the x. For an exponential function, we should be a little bit careful. B is called the base. The base. Okay. Many students confuse exponential function with power function. Guys, note that if you have y equals to x to the n, this guy is called power function. This is power function. Okay. This function, b to the x, is called exponential function. Your exponent is a variable. Your exponent is x, exponential function. Power function, x to the n, like x squared, x cubed, x to the 4th, and so on. These are examples of power functions. B to the x is called exponential function. B is the base of your function. So, talk about the graph. Sure. If the base b is larger than 1, then the graph is an increasing graph. Increasing. You can always use Desmos, double check your graph. If b is in between 0 and 1, we have a decreasing graph. B is between 0 and 1, like a half, a third. Your graph is going to be decreasing graph. Decreasing. So for example, if you have f of x equals to 2 to the x, you expect the graph to behave like this, because b is 2, the base, and the base is larger than 1. However, if you have f of x equals to a half to the x, your base is a half. Your base is in between 0 and 1. So we expect the graph behaves like this, decreasing graph. The next parent function that we're going to talk about is actually the inverse of the exponential function. We call it logarithmic function. So the inverse of exponential function defines logarithmic function. We're going to talk about it in detail more, but know that for now, that logarithmic function is the inverse of exponential function. We define it this way. We say that y is equal to this function is defined by log with base v of x, or f of x is log with base b of x log with base b of x. This is a logarithmic function. It uses logarithm for the definition of this function. And this is the inverse of exponential function. What do we mean by that? Let us take a look at the graph. For the logarithmic function, we have the following. All depends on the base. If the base is larger than 1, then the graph behaves like this. You have an increasing graph. Increasing. If b is sandwiched between 0 and 1, if b is in between 0 and 1, then your graph behaves like this. So it's the inverse of the exponential function, which is symmetric with the line y equals to x, and the graph behaves like this. So just graph this. We're going to talk about the inverse later. So this is our graph of log if base is between 0 and 1. As you can see, you have a decreasing graph.